Hello again, algebra students. We're going to take all of the stuff that we've been talking about with parabolas, all that vocabulary, and we learned how to do things like find the axis of symmetry, and we found the vertex. Today we're going to use that and continue on so that we can graph a parabola, the entire thing. So we're going to do some of the problems right from your worksheet together, so make sure that you've got that out and ready. This is number 1 from your worksheet. So we're going to find the axis of symmetry. You may want to, right now on your worksheet, write this down. Remember, the axis of symmetry is the x equals the opposite of b over 2a. That's the formula or the equation that we're going to use over and over and over to find that axis of symmetry. When we do that, that gives us half of the vertex, and then we'll substitute back in to find the rest of the vertex. And then we will make a table of values so that we can figure out the other points that we'll be using. And then we can answer some of these other questions after we have it graphed. So the first thing we need is the axis of symmetry. And you know that our equations will always look like this. Ax squared plus bx plus c. So in here, I'm going to start with find the a, b, and c, even though we're not really doing anything with the c yet. The a in this equation, since I don't see a number in front of the x squared, is 1. The b is the number that's in front of the x, and in this case, it's a -6. And the c isn't there. So I could add 0 for the c. All right, so to find the axis of symmetry, and I'm going to apologize, my markers are way bigger. Like when I'm trying to fill this out, I won't be able to keep it in that little bitty square, but you should, or rectangle, you should be able to do this for each problem in here. To find the axis of symmetry, I'm going to say the opposite of b, so instead of -6, I'm going to use +6, over 2 times the a is 1. So this is going to be 6 over 2, which is 3. So I would write in here the axis of symmetry is 3, and I can even say the first half of my vertex is 3. You could even start by drawing in that axis of symmetry. I know my vertex has to be on that line. So I would next find out what the y would be. If the x is 3, the y is going to be 3 squared minus 6 times 3. Well, 3 squared is 9. 6 times 3 is 18. So y is going to be equal to -9. So keep that all in the same color there. 3, -9. I'll tell you, this graph goes 10 in each direction. So 3, -9 is going to be right before the bottom, one before the bottom. So there's my vertex. The next thing you're going to do once you have that is I have to actually find some more points to get this table of values. When I do this, I want my vertex to be in the middle. And I need some numbers for x's that are smaller than that and some that are bigger than that. And I want to keep the numbers right next to it. I don't want to jump to 10 and 15. I would want 4 and 5 as my bigger numbers, and I would want 2 and 1 as my smaller numbers. This is a really good place for a calculator, so if you feel comfortable with how to type this into your calculator, go right ahead. Some of these, especially this one, you should be able to do without your calculator probably, or feel pretty comfortable with this. When I put a 1 into this equation for the x, I would have 1 squared, which is 1. I guess I'm just going to have to write that down right there. Minus 6 times 1 is 6. 1 minus 6 is going to give me a -5. When I put a 2 into that same equation, 2 squared is 4, and 6 times 2 is 12. 4 minus 12 is -8. So these numbers, -5 to -8 to -9, they're all decreasing. Then that 3, -9 should be my vertex. These numbers better come back up again at that point. When I put a 4 in, 4 squared is 16, and 6 times 4 is 24. 16 minus 24 is -8. When I put a 5 in there, 5 squared is 25. 6 times 5 is 30, and 25 minus 30 is -5. You should see some symmetry here. Please don't just do half of the table and just expect that you couldn't possibly make a mistake and just recopy the numbers. We want to make sure that you're getting the correct numbers on both sides. So 1 - 5 is right here. Here's 2 - 8, and then 4 - 8, and 5 - 5. So there's 5 points. You could certainly get more points. So for instance, I usually like to put a 0 in here also, not that you would have to, but if I had 0 for x, well, it'd be 0 minus 0 is going to be 0. This would go through the origin, not that you have to have that point graphed, but you might want to. When you graph this, this should be a smooth curve. Notice that my lines are going almost vertical. Please don't get past your last point and then kind of go, wah, it's going to come way out here, because that's not what a parabola is going to look like. After you've got a couple of points graphed, the sides get really steep, and it should be giving you almost vertical sides on there. So there's number 1 done. Let's jump to number 3. I want you to remember that when we're doing this, we have y equals ax squared plus bx plus c. A is easy, that's -2. The b though, I worry that some people are just going to say, oh, it's 1, because it's the next number. But the b is always the number that's in front of the x, and I don't have a regular x here. It's like I said that this was 0x in the middle of this, and then the c is equal to 1. So when I use my axis of symmetry and I say x equals the opposite of b, well, the opposite of 0 is 0, and 2 times a, well, I'm going to say I kind of don't care what the denominator is, because 0 divided by anything is going to be 0. Right? This would really be 0 over -4, but that's just 0. So my axis of symmetry is at 0, which is saying it's going to be using the y-axis as my axis of symmetry. The first half of my vertex is 0. I just realized that I never finished the first problem. After we did all the work, I forgot that we have to say that that vertex is actually a minimum because it's the very bottom of the graph. And the solutions are where it crosses the x-axis. And I didn't do a very good job here of graphing this, but getting some symmetry here, I should be getting that this is going to cross at 0 and at 6. Okay, sorry about that. Oh, let's go back to this one now. I know where my axis is. I know my vertex is going to start with a 0. When I put a 0 in for the x, I would have y equals -2 times 0 squared plus 1. Well, 0 squared is 0, times anything is 0, plus 1 is just going to be that y is equal to 1. So my vertex is at 0, 1, right there. When I make my table of values, again, I want my vertex, that's 0, 1, to be sort of in the middle. When I pick other numbers, I want to, again, keep it close. -1, -2, and +1, +2. I like my numbers to be increasing on my table, and I like to see them in a pattern. I would not want to have like 0, 1, 2, and then -1, -2. It'll give me all the same information. It just doesn't show me the symmetries nicely. When I put in a -2, now here's where you'd have to be really careful. But you can also do this on a calculator. If you can type this in very carefully in your calculator, you're going to be putting different numbers right here for this x. You could, on your calculator, type in a -2. Then in parentheses, put in the number that you're squaring. So I'm going to square a -2. And then you use your exponent of 2 and say +1. Your calculator will do all of that. And then you can just go back in and change the -2 into a -1. Get that answer. Change it into a +1. Get that answer. If you know how to do that, great. If not, you can certainly handle this without doing all that work. But -2 squared would be +4. So I'm going to have Negative 2 times 4 would be negative 8, plus 1 is going to be negative 7 on that. When I put in a negative 1, negative 1 squared is 1 times negative 2 is negative 2, plus 1 is negative 1. Now, if we did this right, we should see some symmetry on the other half of this. When I put a positive 1 in there, 1 squared is 1 times negative 2 is negative 2, plus 1 is negative 1. And when I put a 2 in there, 2 squared is 4 times negative 2 is negative 8, plus 1, negative 7. When I graph this, negative 2, negative 7 is right there. By the way, I also know that it's going to be positive 2, negative 7, so I could get that quite right away. Negative 1, and 1, negative 1. When we do this, I can tell now, because that vertex is the tallest part of my graph. That is a maximum. Now, one issue that I have with this, the solution is where it crosses the x-axis. And it did not cross the x-axis at whole number points. So sometimes we might have to do some estimation, maybe. On this one, it's clearly the same distance away from the origin on each side. And I would say it's not really going to be exactly a half, but if you would say that it's probably at about negative 0.5 and positive 0.5, that would be close enough for now. When we have test questions about this kind of thing, we will definitely make sure that we've got graphs that have very nice, very obvious solutions for where it's crossing the x-axis. Number 5, so this is now on the back side of your graph. When I find my A, B, and C, A is 2, B is 4, C is negative 3. My axis of symmetry is going to be the opposite of B, so negative 4 over 2 times A, which is 2. So I would have negative 4 over 4, x is going to be equal to negative 1. That's my axis of symmetry. That's also where my vertex will start. I could draw in my axis of symmetry. Then to find the y, I would put a negative 1 in for the x. So I would have y equals 2 times a negative 1 squared plus 4 times negative 1 minus 3. Right, I'm going to show all the substitution on this one for sure for the vertex. Negative 1 squared right here is 1 times 2 is 2. 4 times negative 1 is negative 4. So I will have 2 minus 4 is negative 2. Negative 2 plus a negative 3 would be negative 5. So my vertex will be at negative 1, negative 5. Oh, that doesn't seem right. 1, 2, 3, 4, 5, right there. Now I need my table of values. If my vertex is at negative 1, negative 5, I would want to have negative 2 and negative 3 as smaller numbers, and 0 and 1 as bigger numbers. This is where, again, if you're good with your calculator, this could save you some time. I'm going to just do this and just write down what I get after each substitution. So when x is negative 3, negative 3 squared, putting it in right here first, would be positive 9 times 2 is 18. 4 times negative 3 again would be negative 12. And I do that part in my head right away. 18 minus 12 is 6. And then I still have that minus 3 from my equation. So 6 minus 3 is going to be 3. Then I would have negative 2 to go into both of those x spots. Negative 2 squared is 4 times 2 is 8. 4 times negative 2 is negative 8. Well, that part now is 0. minus 3 would be negative 3. When I put in 0, 0 is my favorite thing to substitute. You should know that by now. When I put the 0 in for the x, I'll have 0 plus 0 minus 3 is negative 3. And look, those match, and they should. When I put a 1 in, 1 squared is 1 times 2 is 2. 4 times 1 is 4, so that's 6 so far, minus 3 would be 3. So if I graph that, negative 3, 3, negative 2, negative 3, then we had our vertex, 0, negative 3, and 1, 3. So here's my graph. And again, we're going to have to make some estimations here. My solutions, well, I can first answer, the vertex is actually the minimum on this one. It's the lowest point in the graph. My solutions are where it crosses the x-axis. Well, this one, we could say is probably at about 1/2-ish. And this then would be at a negative 2.5 maybe. I'll put 0.5 just so it's a little bit more obvious. Okay, we're going to skip over a couple more. We're going to do number 8. It's going to be the last one that we do together. So let's find our A, B, and C. A is negative 2. B is negative 8. C is negative 3. I'm hoping that that's feeling pretty comfortable now. The axis of symmetry is the opposite of negative 8, which would be 8 over 2 times negative 2, which will be 8 over negative 4. So x equals negative 2. X equals negative 2. The vertex is negative 2. My axis of symmetry, I can graph right here at x equals negative 2. Now I can find the y. Negative 2 times negative 2 squared minus 8 times negative 2 minus 3. So, order of operations, remember, this is going to be positive 4. Negative 2 times negative 2 is 4. Times negative 2 would be negative 8. Negative 8 times negative 2 is positive 16. So far right there, I've got 8 minus 3 would be 5. So negative 2, positive 5. It's right there. I'm going to make my table of values. Negative 2, 5. I would have negative 3 and negative 4, and I'd have negative 1 and 0 as my smaller and bigger numbers. When I substitute in negative 4, again, we're substituting in both places with the same number. Negative 4 squared is 16, times negative 2 would be negative 32. Negative 8 times negative 4 is positive 32. So those two are going to cancel out, and then I still have minus 3. So that's just going to be negative 3. When I put in a negative 3, negative 3 squared is 9, times negative 2 is negative 18. Negative 8 times negative 3 is positive 24. If I would just add just those two right now, I've got 6 minus 3 would give me 3. When I put in a negative 1, negative 1 squared is 1, times negative 2 is going to be negative 2. Negative 8 times negative 1 is positive 8. That's also going to be 6 when I add those. 6 minus 3 is 3. And when I put in a 0, first part is 0. The second part is 0. That's just negative 3. So negative 4, negative 3, negative 3, positive 3, negative 1, 3, and 0, negative 3. Whoop. My graph got a little crazy there. I went over too far. So this is not quite going to get all the way over to where that big thick line is that I just drew. But that vertex is a maximum. That is the tallest point that it gets to. The solutions, again, not nice numbers, and I apologize for that. But right here, probably is at negative 1, 2, 3, let's say negative 3.5-ish. And the other one is at negative 0.5. So that is almost all of your worksheet. And I'm going to say, you know what, skip 2 and 4 from the front side. All you have left to do are 6 and 8 on the back side. Do your best on those. There is going to be a formative in Schoology. The answer key is also going to be in Schoology. And let your teacher know if you need any help.